Hi-oh! Here we are again with electric circuits and their components. All electric circuits have three components. They have current, voltage, and resistance. They all work together. You cannot have one without the other. There's always going to be all three. If you don't, you no longer have a circuit. Current itself, as it suggests, is the flow. And since we're talking about electricity here, we're talking about the flow of charge, specifically electric charge. When it comes to current, we measure it in something called amps or amperes, named after André Marie Ampère, and we use an I. The reason for using an I is that the gentleman realized the connection between the different circuits, the different components of a circuit, was measuring not necessarily the current, but the intensity of the current. So we used an I. So remember, current is the movement of charge. The electrons, yeah, they move, but it's the charge that supplies us the electricity. We can make current move in two different ways. One is a direct current. In other words, it's like you'd expect a battery. You have one side negative, the other side positive, and the charge goes from one side all the way around to the other side. Just one direction. It's direct. One direct route. But the way that the electric company produces current is called alternating current. The generator itself causes the electrons, and therefore the charge, to vibrate at 60 times a second. So as you can see in our picture, it goes one way and then it goes the other way. 60 times in a second. The second component is the electric potential. Again, we call it, you probably remember from a previous unit, we call that voltage, measuring it in volts. You can think of this as the pressure behind moving that charge. If you have a dead battery, there's going to be no flow of charge. And so it's the push. There's got to be a push. When we take and put water up in a water tower, that the push of gravity's pulling that water down, that supplies the push to move the water. Very similar to the voltage of a battery supplies the push. In fact, it's much more similar than you might think, because things travel from a high to a low potential. Remember that potential energy idea? A lot of potential energy on one side of this battery and less on the other side. So the current, the charge, wants to flow from one side, from the high side, to a low side. You can think of it as work needing to be done. So when you put together, we've talked about batteries. When you have two batteries, what is the difference between a AA and a D, or a AAA and a AA? They're both 1.5 volts. They both have 1.5 joules of energy per coulomb of charge. But the D can store so many more charges. It lasts longer. So to make that connection between voltage in a battery and the analogy of water, the voltage supplies push for electrons to move and the charge to flow, just like a pump supplies the push to make water flow. And likewise, the water is already in the pipes, and so are the electrons already in the wires. Now, let's put this to a real-life example. You've seen birds perched on a wire. Why don't they get fried? Well, if there's no difference in potential, in other words, a voltage difference from one side to the other, there's no reason for the current to flow. We would say bird B is at the same potential. However, bird A, this bulb is using some of that push. It's using up some of the energy. And therefore, one side is at a different potential than the other side. And because of that, electricity is going to flow, and in this case, flow through the bird, and he is toast. Third part is resistance. Just like we have water flowing through a pipe, we have something pushing the water, and water is gravity. Gravity pushes the water along from a high elevation to a low elevation. Well, there's rocks in the stream. And the rocks, or the dams we built, prevent the flow. Well, it turns out wires are no different. They can offer a lot of resistance, just like putting rocks into a stream, or even more resistance, like damming up a stream, preventing it from flowing. Anything that uses electricity acts as a resistor. When it comes to looking at the wire itself, you can think about this. A stream that's very, very small has a lot of resistance. Not much water can flow. It's very small. But if you have a much bigger basin, the water can flow easier. There's less resistance. Wires are no different. Bigger the wire, not longer. The wider the wire, the less resistance. Let's put it all together. Electricity versus your plumbing of your house. The charge itself is similar to the water. The current is the flow. The battery is like the pump. Voltage is that push or the pressure to get it moving, and the wire would be the pipes.